Hi everyone. Today we'll try to understand what is Nash equilibrium in game theory and also the mathematical part of Nash equilibrium alongside the example. So Nash equilibrium is a very important concept in game theory. Let's understand what is Nash algorithm, Nash equilibrium. So basically, in an environment, Nash equilibrium is a stable state where none of the players involved can get a better result until unless the opposite player, the opponent, changes his strategy. So this is a bit complex to understand, so we'll go run through an example as well. But first of all, let's understand what are the different terminology that we need to know. One is stable state, a state from which outcome for no player can go worse. This is very important. It can improve but can't go worse. This is called as stable state. An unstable state, opposite of that, that means the output can go worse for one of the players. An optimal state is the one which produces the best result considering both the players. So we will see in the example how what is an optimal state. An equilibrium. It is the most stable or balanced state possible in the environment. Right. So Nash equilibrium, we will be remembering two major points. One is that Nash equilibrium is a particular state where the output, the result for a particular player can't go worse. Um, and even if he changes his strategy, his result can't improve. So it is a situation in which the player can get better results if the opponent changes his strategy. Else, he's getting this is as the bare minimum. His condition can't go worse. So let's understand with an example. Assume that we have two siblings, Neeraj and Aditi. Their mother is suspicious of them that they eat the chocolates in the fridge that she has kept. So she has put on some punishments for them. Depending upon the answer she receives from them, she is asking them, okay, who has eaten those chocolates, and depending upon the answer, she would be deciding what the punishments for them. So if Aditi and Neeraj both accepts, okay, we have eaten the chocolate, they both get 3 weeks punishment. If Neeraj denies but Aditi accepts, then Neeraj gets 10 weeks of punishment, but Aditi gets 1 week of punishment. Vice versa. If Aditi denies and Neeraj accepts, Neeraj gets 1 week, Aditi gets 10 weeks. Similarly, if both of them denies together, they get 2 weeks each. Now, how we would be using Nash equilibrium in this particular situation? So, Nash equilibrium will help us to reach an ideal strategy that both the players, that is Neeraj and Aditi, should follow up to get to the most optimal outcome, depending that they don't know what the opponent has taken, what the opponent has chosen. Because in such situations, you can see that your result, your output is not dependent upon your actions only, but on the actions of the opponent as well. So here, Nash equilibrium plays a very important role to help with the player and choose the best situation, the best option to take, depending upon all the possible options he has got. So in this particular case, assume that we have four states. State one, this is state one where both of them accept. This is state two. This is state three, and this is state four. Now, in this particular case, the Nash equilibrium state is state one. That is Neeraj and Aditi both accept, and not state four, where both denies but get 2 weeks. So let's understand how this is happening and why other states are not Nash equilibrium. So in this case, if you look from Neeraj's perspective, if Neeraj is accepting, he's getting 3 weeks. If he changes his strategy, he goes to denial. He gets 10 weeks. So it's his situation is worsening. So if you remember in Nash equilibrium, what we told ki your situation can't go worse than that. Hence, if you stick to your decision. So the first point is correct. If he remains at accept, and if Aditi changes from accept to denial, his position can improve. He gets 1 week as a punishment, but he can't go to 3. He can't go to 10 because if he denies, then he go to 10. But he is not. If he's sticking to his particular strategy, he won't. His condition won't go worse. Again, in case of Aditi, she's also getting 3 weeks of punishment. But if she doesn't changes her strategy and Neeraj changes his strategy, so she get a improvement of 1 week in punishment. Hence, her condition has improved but not degraded. If Neeraj sticks to 3, she's getting 3. If Neeraj denies, she gets 1. Hence, state 1 is Nash equilibrium. Now talking about state 2 and state 3. So these two states are unstable states. So if you remember the first definition that we told, an unstable state is the one where the output for one of the players, if he changes his strategy, can go worse. So for example, or can improve. So for example, if you can see that in case of state 2, Aditi has got 1, Neeraj has got 10 weeks as punishment. Now if he changes his decision to accept, he gets 3 days of 3 weeks of punishment. Hence his situation improves. Hence this situation is not stable for Neeraj. Similarly, state 3, Aditi is getting 10 weeks of punishment, but Neeraj is getting 1 week of punishment. So if Aditi changes her strategy, she gets punishment of 3. That means her situation is also improving. So state 2 and state 3 are unstable states because if the player changes his strategy, his situation can improve. So if you remember from Nash Equilibrium's definition, the player, if he doesn't change his strategy, and if the opponent changes his strategy, his situation can only improve. It can't go to worse. Now talking about state 4, both of them are getting 2 weeks of punishment. But if you again can see, if Neeraj, if Aditi accepts and Neeraj denies, because this is both denial. If Aditi accepts, so she's getting 1 week of punishment. So again, it becomes an unstable state. It is the optimal state because it has producing the best outcome in case of considering the whole situation. But if Aditi goes for acceptance, she gets 1 week of punishment. Similarly, if Neeraj goes for acceptance, he gets 1 week of punishment. Hence, their situation can improve from these conditions. Hence, these are not Nash equilibrium states. So again, state 1 is Nash equilibrium state because if any of the opponent changes his strategy, that if Aditi goes from acceptance to denial or Neeraj goes from acceptance to denial, the opponent gets benefited from it if he sticks to his strategy, and he can't improve his and he can't improve his condition by changing his strategy. So if Aditi sticks to accept but Neeraj denies, so he gets his condition worsen out. Similar for Aditi also. Hence, state 1 is a Nash equilibrium state in this particular situation.